Hi everybody, today we're going to do lesson 7-12 and that is going to be factoring trinomials, which I know we've done before, but there's a little something different in this one today. Okay, so let's start with an old one, a review problem. So x squared plus 2x minus 8. All right, if you recall, we made our x, we put the last number in the top, we put the middle number in the bottom. Then we found factors of 8, 1 times 8, 2 times 4. That would either subtract or add to be 2. So we have 4 minus 2. Look at this. 4 minus 2 is 2, and 4 times negative 2 is negative 8. Those are our two numbers. So we double bubble x plus 4, x minus 2. And that is our final answer. That is this the trinomial written as the product of two binomials. That's what they call it. Okay, so let's try another one. Okay. All right, this one is going to be 6x squared plus 23x and then plus 7. Okay, we'll do our x. Last is 7. Middle is 23. Okay. 1 times 7. Something's wrong here. Well, look at the problem we're doing. This is number 1. Look at the problem we're doing. What is different about this one from every other problem we have done before in factoring trinomials? Okay, so there's a 6 at the front here. Every other trinomial we've done has started with x squared. All of a sudden we have a 6 in front of it and it doesn't work. Okay, so I'm going to cross out this guy here. I'm going to rewrite the x, because what we really need to do here is we need to multiply the first coefficient times the last term there. So 6 times 7. Now, 6 times 7 is 42, and that's what we put in the top. So this guy here was just the last. Now it's first times last. Okay? In the middle one just goes in the bottom like we've always done. Okay, now if you take a look at this circle, this whole thing, my daughter's teacher called it the eyeglass theory, and for some reason the kids always remember that. So that's what we're doing there. Now we have to find factors of 42. Everything else is the same here. 1 times 42, never going to be a 23. 2, nope, yeah, 2 times 21, 21 plus 2 is 23. And 2 times 21 is 42. So it's 21 and 2. Okay? All right, this is where it gets different. We're going to rewrite this as 6x squared and 7 on the ends. Then we're going to take the 21 and 2, and we're going to rewrite this middle term as plus 21x and then plus 2x. And the 7 was a... So you see, we're just rewriting this. It's equivalent expressions. We're just rewriting it in a different way. So now, look what we have. We can do factor by grouping. Okay, we have 4 terms here, so we're going to break it up. 4 terms is too many. We are going to take out the greatest common factor of the first set of parentheses. So that's going to be 1 times 6, 2 times 3. 3 goes into 21. So we're going to divide by 3. Can we take an x out of each one of them? Yes, we can. All right, 3x comes out. Whatever's left over gets written inside. So this is going to be a 2x. And this is going to be a positive 7, so plus 7. Okay. The second term, the largest or the greatest common factor is a 1. There's no other factors of 7 and 2 that are in common. So we take out a 1. Okay, if you divide by 1, you get the same thing you had, 2x plus 7. Right, so now we have common polynomials here, common binomials. They come out as one factor, and the other factor is 3x plus 1. And that's all the steps. Okay, it's quite a few steps. If you need to go back and listen to it again, be my guest. I'm just going to do one more today, and then we're going to do some more tomorrow. I try to keep these videos under 15 minutes, and if I do 3 of them, I'm not going to make it. Okay, so let's do example number 2. Example number 2. Okay, what is example number 2? How about 3x squared plus 4x minus 15? Okay, so to fill in our x, we have the eyeglass theory going on here. We have a first times a last. Whoops, whoa, bad eyeglasses. Sorry about that. That's confusing. I don't like that. Okay, so this is the way it should look. So 3 times negative 15 is going to go in the top here. This is first times last. 3 times negative 15 is negative 45. In the bottom, we're just going to put the 4 like we always had. This is the middle. Middle goes in the bottom. We're looking for two numbers that multiply to be negative 45 now, but add to be a 4. So let's see. We have 1 times 45. No, we don't have 2. Do we have 3? Yes, we have 3 times 15. Oh, yeah, I knew that. And then we have 4 doesn't go in. 5 goes in 9 times, so 5 times 9. Oh, wait a second. 9 minus 5 equals 4. And 5 times 9 equals, oh, well, we need a negative here, so negative 5. Okay, so 9 minus 5 is 4, and 9 times negative 5 is negative 45. We are going to rewrite this problem. A 3x squared gets brought down. A negative 15 gets brought down. And the middle term is going to be rewritten as plus 9x minus 5x. And that's only because 4x is equivalent to 9x minus 5x, so we can rewrite it that way. We're going to factor by grouping now. Okay, so we're going to put this 4 terms into 2 groups of 2. We're going to look at the first term. What's the greatest common factor here? Well, I have a 3 here, and 3 goes into 9. I also have an x I can take out. There's 1 here, and there's 2 over there. So it's 3x. What's left over after you divide by 3x is x plus 3. Okay, now the second binomial, we're going to take out a 5, right? Oh, wait a second. No, let's take out a negative 5. Remember, you take out the negative when there is one. If we're dividing by a negative 5, this is where you have to be careful. Negative times negative is a positive. It's going to be a positive x. And then this is going to be a negative 15 divided by a negative 5, which is going to be a positive 3. And you know you did that right when you get matching binomials there. So we're going to divide out the x plus 3. And what we have left over is 3x minus 5. And that's the second problem. Okay, I think I'll only put one up for you to do. I don't want you to get too frustrated with it. I'd rather you listen to the video again if you have time. But let me put the 2 problems up for you. Oh, no, I said 1. Haha. Okay, so here's your 1 problem. So pause the video, work out this problem, come back, check your answer. Do not copy my answer unless you got yours wrong and you don't know why. Do your own work, please. Okay, if you got x plus 6 times 2x plus 1, you got it right. Oh, you know, I keep meaning to tell you this. If you write it as 2x plus 1 times x plus 6, that's fine also. It doesn't matter what the order of the binomials is. It does matter what the order inside is. So 2x plus 1 has to be in that order, but 2x plus 1 times x plus 6 can be written as x plus 6 times 2x plus 1. So that's fine also. Okay, that's it. We'll do some more tomorrow. Have a great day.